Hello and welcome to my channel. My name is Aryan, and before starting today's video, I want to give you the name of book that you can use as a reference for my content. Book name is Computer Oriented Numerical Method by V. Rajaraman. I also want to give credit to Saligram Prajapati sir, who has an incredible source of knowledge and support. Now let's get into today's content. Okay, the topic name is Interpolation in its type. Interpolation is a technique for estimating the value of function for any intermediate value of independent variable. There is an extrapolation also. The process of computing the value of function outside of the given range is called extrapolation. Type of interpolation. Mainly there are four types of interpolation. Newton-Gorgy forward interpolation. Another is Newton-Gorgy backward interpolation. The third is Newton divided difference interpolation. And the fourth one is Lagrange interpolation. Let's go one by one. Newton-Gorgy forward interpolation formula. This formula is particularly used for interpolating the value of f of x near the beginning of the set of the value given. H is called the interval of a difference and u is equal to x minus a divided by h. Here a is the first term. The order of polynomial used in Newton forward interpolation is n minus 1. It is important that the order of polynomial in Newton forward interpolation is n minus 1. It's n minus 1. Advantage of forward interpolation. It is used for large value of n. That is, it is computatively intensive. It means it is used for large number of values. Okay. Now Newton-Gorgy forward backward interpolation. This formula is used when the value of f of x is required near to the end of the table. Here, the value should be lie at the beginning of the set of value. Here, in backward, it will at the end of the table. H indicates the interval of difference, and u is equal to x minus a into n divided by h. Here, n is the last term and a is the first term. Advantage of backward interpolation. It cannot be used for a large number of value. It is only used in the finite value, like fixed value. You can say that 1 to 100 or etc. Third is Newton divided difference interpolation formula. This method is also known as the finite difference. Okay, it is interpolation technique used when the interval difference is not same for all the sequence of value. Suppose fx0, fx1 till fxn be the n plus 1 value. Here n plus 1 value is 4 because we are also considering fx0. The value of function is y fx हो जाए है correspond to the argument x is equal to x0, x1, x2 till xn, where interval difference are not same. The first divided difference, we can say that the first divided difference will look like f of x0 comma x1 will be fx1 minus fx0 divided by x1 minus x0. Some general points related to Newton divided difference are in Newton divided difference interpolation formula, we use high order difference to increase accuracy of interpolation. Also, in Newton divided difference formula, there is a we cannot use polynomial approximation. At place of a polynomial approximation, we use Newton format. Fourth one is Lagrange interpolation formula. Lagrange interpolation formula find a polynomial called Lagrange polynomial that takes a certain value at arbitrary points. It is an n-degree polynomial expression to the function f of x. The interpolation method is used to find the new data point within the range of a discrete set is known as data point. It is more suitable for unevenly spread data points. Also, interpolation error occur in Lagrange interpolation formula. This is the Lagrange interpolation formula where f of x is equal to x minus x1, x minus x2 till x minus xn. Here x0 is not considerable, but at the here x0 minus x1 x minus x0 minus x2 till xn into y0. हियर x माइनस एक्स जीरो, यहाँ पर x1 को हमने छोड़ दिया है और x माइनस एक्स टू कर दिया है, सीधे ले नीचे x1 को कंसिडर करके x0 के साथ टिल xn तक लिया इनटू y1। सेम प्रोसेस अपन रिपीट करेंगे टिल xn। हियर वी डोंट टेक xn। Okay, now these are the four methods we use. Using these four methods, we can derive some rules like trapezoidal rule, Simpson one-third rule, and Simpson 3/8 rule. When we put 1, we got trapezoidal rule. Trapezoidal rule is one of the more important integration rule. The name trapezoidal is because when the area under the curve evaluate, the total area is divided into small trapezoids. Uh, that is triangle. This rule is used to approximate the defined integral where it is used linear approximation of a function. Now, this rule is also mostly used in numerical analysis process. Simpson one-third rule. Simpson one-third rule is a extension version of trapezoidal rule, in which the integration is approximated by the second order polynomial. Also, this is the first order polynomial. Here it is a second order polynomial. Similarly, the rule can be derived in various ways using Newton divided difference, polynomial, Lagrange interpolation, method of configuration. Simpson one-third rule can be defined as uh, a to integration from a to b f of x dx h divided by 3 multiplied by first term minus first term plus last term, that is y0 plus yn plus 4 multiplied by all the odd term, it is y1 y3 y5 sum of all odd term, and plus 2 multiplied by sum of all even term. This is Newton one-third rule, also known as one-third rule, Simpson one-third rule. Now Simpson 3/8 rule. Another method of numerical integration is known as Simpson one-third rule. It is completely based on the cubical interpolation rather than quadratical interpolation. Similarly, one-third rule is also the formula of one-third rule is uh, range from a to b, integration from a to b fx dx is equal to 3 into h divided by 8 multiplied by first term minus last term, that is y0 plus y, and first term plus last term plus 3 multiplied by sum of all the term which are not divided by 3, that is y1 y2. We neglect y3 because 3 is divided by 3 till yn minus 1. Now uh, 2 plus 2 multiplied by all the multiples of 3, that is 3 6 9 till n minus 3. This rule is more accurate than the standard method. Thank you.